Hello students, in today's session of NCERT Chapter Thermal Properties of Matter, very basics of the topic Principle of Calorimetry is going to be cleared through illustrations. In earlier session, we have gone through very basic one on the topic of thermometry and thermal expansion, which you can review on YouTube channel sethiswiftlearn. In today's session, we are going to discuss what is heat capacity, what is specific heat capacity, what is principle calorimetry, how to convert minus temperature ice to steam, and other number of illustrations, which is going to be very important for 11th standard, NEET exam, JEE, CUET, and other entrance examinations. It is requested go through the complete session. Now let's start with the concept and question. Question is, how much heat is required to convert 8 gram of ice at minus 15 degrees centigrade to steam at 100 degrees centigrade? These are the given parameters. Specific of height is ice is given, latent heat of ice is given, latent heat of steam is given, specific heat of water is given. Concept, applicable and solution. What is calorimetry? It is a branch of science that deals with the measurement of heat. When a body at high temperature is brought in contact with another body at lower temperature, then the heat flows from body kept at high temperature to body kept at lower temperature till both bodies acquire the same temperature. That is the temperature of equilibrium. Thus, the principle calculator states that total heat given by the hotter body equal to the total heat received by the colder body. The basic principle of calorimetry is this one. Heat lost by hotter body is equal to heat gained by the colder body. Right? If there are two bodies of masses M1 and M2 and having values of specific heats C1 and C2 respectively, then for temperature differences, delta theta1 equal to delta 2. Heat lost by one body equal to heat gained by the another body, according to this. Right? Change of state. Change of state may be from solid to liquid or liquid to solid, vice versa. Heat loss or gain is equal to M into L. L is the specific heat. Latent heat. Liquid to gas or gas to liquid. That is M into L. L may be for ice, L may be for steam, or any other. Latent heat. What is latent heat? It is denoted by L, the amount of heat transferred per unit mass during the change of phase of substance without change in its temperature is called the latent heat substance for particular change. Essential condition is temperature does not change during the change of state. Therefore, it is known as a latent heat. Right? It is denoted by L. Latent of steam is 540. That of ice is 80 calorie per gram. Specific heat of ice is 0.5 calorie per gram per degree centigrade, and specific height water is 1 calorie per gram per degree centigrade. If in the question nothing is stated, you can consider these values. Now let's start with the solution of the question. Solution of the question is, now there are how many stages will be there? One will be change of temperature, and what is change of state? Change of state may we use the concept M into L, in this MC delta theta. Now, in this case, this will be minus 15 degrees centigrade ice to 0 degree centigrade ice. then 0 degree centigrade ice to 0 degree centigrade water, ice. Then 0 degree centigrade to 100 degree centigrade water. Then 100 degree centigrade to 100 degree centigrade steam. Water to steam. This is change of state. This is change of temperature. This is change of state. This is change of temperature. If there is change of temperature, use the concept m into c into delta theta. In this case, m into L. In this case, ice. In this case, m into c into delta theta for water. In this case, m into L, steam. Right? 1 gram of both. This is given 8 gram. 8 into 0.5 into temperature is minus 15 degrees centigrade. Final minus initial. 0 minus 15 degrees centigrade. This comes out to be plus change of state 8 into 80, right? Plus change of temperature 1 into 100 minus 0 plus m into L, that is 1 into 540. 1 into, sorry, this is 8. This is 8. This is 8, right? If we add all these things, we get 5815.6 calories. Amount of heat required to convert 8 gram of ice at minus 50 into 100 degrees centigrade is this much amount of heat is required. Amount of heat required to minus 50 degrees centigrade to 100 degrees centigrade steam of 8 gram. This is the answer. There are how many cases? This is Q1, Q2, Q3, Q4. Change of temperature, change of state. Change of temperature, change of state. Right? Next question. Question is 1 gram of ice at 0 degree centigrade is mixed with 1 gram of steam at 100 degree centigrade. After thermal equilibrium achieved, the temperature of the mixture is. 4 options are given to you. One of the options is correct. Concept applicable and solution. First is principle of calorimetry. Principle of calorimetry states that heat lost by the hotter body is equal to heat gained by the colder body. If these parameters are not given, we have to consider these one. Latent heat of steam is 540 calorie per gram and that of ice is 80 calorie per gram. Specific heat of ice is 0.5 calorie per gram per degree centigrade and that of water is 1 calorie per gram per degree centigrade. If the question is given, that pick up that, otherwise you have to consider these things. Now in this case, let temperature at thermal equilibrium be theta. Then according to principle of calorimetry, heat lost by steam will be heat gained by ice. इसमें क्या आएगा? M into L, conversion of 100 degree centigrade steam to 100 degree centigrade water plus M into C into delta theta. Conversion of 100 degree centigrade water to theta degree centigrade. That is equal to M into L. Conversion of 0 degree centigrade ice to 0 degree centigrade water plus m into c into delta theta. That is 0 degree centigrade to theta degree centigrade. Right? Now substituting 1 into 540 plus 1 into specific water is 1 into 100 minus theta, right? 1 into 80 plus 1 into theta minus 0, right? This is your heat loss by this and heat gain by this. 540 plus 80, 100 minus theta equal to 80 plus theta. Then 2 theta comes out to be 640 minus 80. That comes out to be 560. 2 theta. Theta comes out to be 280 degrees centigrade. Now, in this case, as theta mixture greater than highest temperature of the system, pick up highest temperature as answer. And if theta mixture less than the lowest temperature, pick up lowest temperature as answer. Right? In this case, highest temperature is 100 degrees centigrade. In the given question, highest temperature is 100 degrees centigrade and lowest temperature is 0 degrees centigrade. It is coming for higher than 100, so pick up 100. So this is the correct answer. Correct answer. Answer option A is correct. Option A is correct. Option A is correct answer. Right. Next question.
Before start of the next question, I would like to say that these concept killing videos for the purpose of 11th standard, 12th standard, state boards, CBSE board, JEE Main, JEE Advanced, NEET, CUET, and other entrance examination. These concept killing videos are very helpful and useful, which you can review on YouTube channel sethiswiftlearn. In addition to this, I would like to say that these papers, complete video of discussions are available on sethiswiftlearn YouTube channel, which you can review on sethiswiftlearn. In addition to this, further, these papers, detailed solution with additional information available on website sethiswiftlearn.com. You can visit the site and have the solution. इसी के साथ साथ मैं रिक्वेस्ट करना चाहूँगा कि अगर अभी तक आपने YouTube चैनल sethiswiftlearn सब्सक्राइब नहीं किया, प्लीज सब्सक्राइब इट एंड शेयर विद योर colleagues and friends. Now let's start with the question.
Question is, which of the substances A, B and C has the lowest heat capacity if heat is supplied to all of them at equal rates? Temperature versus time graph is shown here. 4 of the options are given to you, 1 of the option is correct. Concept applicable in solution. What is heat capacity? It is defined as the amount of heat needed to change the temperature by unity, that is 1 degree centigrade. It is denoted by capital C and is equal to dq by delta q by delta theta. And what is specific heat capacity? The amount of heat needed to raise the temperature of unit mass of a substance by unity is known as specific heat capacity or specific heat. It is denoted by small c. One is capital C, one is small c. And that is equal to capital C by m. This is the formula. This is the formula. Now, according to question, If heat is supplied to them at equal rates, heat capacity equal to delta Q by delta theta, delta Q by delta theta, as delta Q is same. Therefore, C delta theta equal to constant for all the three. Means higher the C means longer the time taken to heat to higher temperature and longer the time taken to get cooled. Now, if we draw a horizontal line like this and draw the projection this is TA, TB, this is TC. What we have to find? Temperature, lowest heat capacity will be that will be of A. Higher the heat capacity, higher the time taken. So TC is greater than TB, greater than TA. Right? So heat capacity will be minimum of A. So A is the correct answer. A option is correct answer. Right? Next question. Question is, a ball of mass 1 kg is dropped on the floor from a height of 2 meter. After collision, it rises to a height of 1.5 meter. Assume that 40% of the mechanical energy lost goes as thermal energy in the ball. The rise in temperature of the ball is, heat capacity of the ball is given to 800 joule per Kelvin. 4 options are given to, one of the options is correct. Concept, applicable and solution. Basic principle calorimetry, total heat given by a hotter body equal to the total heat received by the colder body. This is one of the principles. Now in this case, in this particular, 40% of loss of potential energy equal to gain in thermal energy. This is the concept. So 40 by 100 mgh1 minus h2 equal to m into c into delta theta. This we have to find it out. This m goes figure के accordingly. ये drop किया 2 meter, then rebound to 1.5 meter. Then loss of potential energy is there. So this goes 2 by 5 into 10, 2 minus 1.5 equal to 800 into delta theta. Right? Given आपको, so delta theta comes out to be 200. So this comes out to be 0.5. 0.5 upon 2000. That is Kelvin. That comes out to be 2.5 into 10 to the power minus 3 Kelvin, or 2.5 into 10 to the power minus 3 degree centigrade, as change of temperature, delta theta is delta degree centigrade and Kelvin, both are same. In change in temperature, if only temperature, then it is. So this is the answer. Let's see the answer. Answer is D. Option D is correct. Option D is correct. Right? Now, I would like to request, if you are new to my YouTube channel, sethiswiftlearn, please like and subscribe to my channel and press bell icon to receive updates on concept killing videos. Thank you.